Okay, we're going to be simplifying radicals, which is just square roots. I don't know if you guys remember doing factor trees, but I'm going to teach this using factor trees. There is a more advanced way, but I want to make sure you get down the basics, and then I'll get there. So I literally tree 12. I can either do 2, 6 or 3, 4. It doesn't matter what I do. So I'll do 2, 6. Now if you look at the 2 is prime, so you keep going, 2, 3. Now whatever the doubles are, only doubles. The doubles are what goes on the outside. And then we'll talk about this, but what's left is going to go on the inside. So the double goes on the outside, so you're left with 2. And then what's the only thing at the bottom of the tree? Not when there's the 6, because the 6 isn't at the bottom of the tree. So whatever's left goes there. Okay, and we'll talk about later how to check your answers. Let's try another one. 11. I can do, for 54, I can do 6 and 9. I can do 2 and 27. I can do whatever I want. I'll do 2 and 27 because most of you will do 6 and 9. 2, 27. I can't keep going. 3 and 9. Can't keep going. 3 and 3. So I circle the doubles. That's what goes on the outside. And then I write what's left. Well, the 9 isn't left because the 3s are at the bottom of the tree. This is left and that is left. Now when you have more than one thing left, you multiply because this is all being multiplied. 2 times 3, 6. If you know a fancier way, I'm all about it. Let me do one more just in case. Let's do 14. So I'll go 10 and 8. Keep going. 5 and 2. Stop, stop. Keep going. Keep going. Circle the doubles. I have one set of doubles and another set of doubles. If I have more than one, I multiply it. 2 times 2, 4. What's the only thing left at the bottom of my tree? 5. Okay? Let's look at 18. Now in this case, I have a fraction. Don't get scared. Square root the top, 8. Square root the bottom, 11. And that's it. Don't stress. Number 21. Now this time, 21 is actually kind of like 14, except there's a 5 out there. Just pretend the 5 isn't even there and start treeing. 4, 7, 2, 2. Circle the doubles. What's left is the 7. But what makes it different is that you also had the 5 on the outside. So you're going to take the 5, multiply it times the 2 because both of those are on the outside, and that's 10 rad 7. Oops, not 17. Sorry. 10 rad 7. Okay. All right. Let's take another one. This time what we're going to be doing is we're going to be adding them. The problem is we can't add them unless the square roots are the same. So what I mean by that is if I had 3 square root 6 plus 7 square root 6, the answer is 10 square root 6. But if this is different, like if this was a 63, I couldn't add them together. But I'm going to manipulate it so I can. So I look here. If I try to do the 5, 5 is just 5 times 1, so there's nothing I can do. 45, 9 times 5, 3 times 3. Circle the doubles outside. What's left? Inside. Now I simplified this to the best of my ability to 3 rad 5. Now I'm going to take this and bring it down. And since they have the same radical, boom, now I can add them. 6 plus 3 is 9 rad 5. Now, I understand how that can be difficult. I want you to think about 6 rad 5 as 6x. And think of 3 rad 5 as 3x. Well, what's 6x plus 3x? 9x. So that might make it easier to understand. Number 27. They're both different, and I can do something with both. 2, 9, 3, 3. Now these are separate trees, so don't use this tree to help you with the first one. Circle the doubles. 3. What goes left on the inside? 98. I know it's even, so it divides by 2. 7, 7. Circle the doubles. Double goes on the outside. What's left goes on the inside. And there's a plus. 3 rad 2 plus 7 rad 2. 10 rad 2. Again, I will show you how to check these, just not today. Let's turn the page. Now, let's look at number 2. What's difficult about number 2, like it seems fine, but you cannot have a radical in the denominator. So they want you to rationalize it. So if you look over here at this example, the way that they're saying is if you multiply a radical by itself, it eliminates it. Because square root of 2 times the square root of 2 is the square root of 4, which is 2. So if I had rad 7 times rad 7, it's just 7, because that's square root of 49, which leads to 7. So the reason number 2 is not an acceptable answer is because there's a radical in the denominator. Multiply it by itself. 2 times rad 3 is 2 rad 3. Rad 3 times rad 3 is rad 9, which is just 3. Done. Let's look at number 4. Why isn't number 4 good? You can't have a radical in the denominator. Multiply it by itself. 6 times rad 2 is 6 rad 2. Rad 2 times rad 2 is just 2, because the square root of 4 is 2. There's one problem, though. If you look, 6 can divide 2. I can't divide those two, because that is in the radical, and that is not, they are different. But these, since they're being multiplied or divided, I can divide them. 6 divided by 2 is 3 rad 2. And yes, you always need to have a simplified answer. Okay. Let's look at number 11. Number 11 seems very similar to number 4. So you feel like I should go square root of 225, square root of 225. But you can actually figure out the square root of 225. It's 15. So that's all you got to do. So careful of those types of things. If you can simplify it, simplify it. All right, let's look at number 13. The 8 is fine, the 3 is fine, but what makes it not fine is that rad 2. So since it's the square root of 2 that makes it not acceptable, that's what I need to get rid of. That's what I multiply by itself. So 8 times rad 2 is 8 rad 2. Now here's where it gets a little tricky. Rad 2 times rad 2 is 2. But then there's a 3. So 3 times 2 is 6. Let me say it again. Rad 2 times rad 2 is rad 4. The square root of 4 is 2. But then you also had that 3. So you multiply them. 3 times 2 is 6. Now it's still not good, because just like what you did in number 4, you can simplify. 8 and 6 divide by 2. So 4 rad 2 over 3. So there's 4 rad 2 over 3. This is a lot, I know, but you'll practice. Let's turn the page. What makes number 23 not good? The 6 is good, the 2 is good, but the rad 7 isn't good. So I'm going to multiply it by itself. But I was hoping some of you would see that you could simplify the 6 and the 2 just from the start. So that's really just a 3, and that's gone. So really what you should do is just rewrite it as 3 over rad 7. It's just easier. Now go rad 7 over rad 7. 3 times rad 7 is 3 rad 7. Square root of 7 times square root of 7, 7. Done. Okay. This one is a workout, so I'll go kind of slowly. Remember this problem from the previous page, the first page, when I said you had a fraction, square root at the top and square root at the bottom? So that's what I want you to do here. But the problem is it's kind of crazy, because the square root of 5, I can't do anything. The square root of 27, I feel like I can't do anything, but I could tree it. Notice I'm doing a horizontal tree this time. Okay, circle the doubles. That goes on the outside. What's left goes on the inside. So I'm rewriting the top. There's the bottom. Rad 27 is 3 rad 3, and then there's a negative 3. Well, the negative 3 is like 3 over 1, so I can simplify. And now it becomes negative rad 5 over rad 3. Now here's the deal. You can have a radical on top. You can have a negative on top, but you can't have a radical in the bottom. Multiply it by itself. Let's take care of the bottom first. Rad 3 times rad 3, square root of 9, which is 3, negative. And the square root of 5 and the square root of 3 is the square root of 15, and you're done. Now I want to be clear. If you had 5 and then you multiplied that by rad 3, that's just 5 rad 3. But when you have rad 5 times rad 3, that's rad 15. And then if you had this problem, where if it's, like if you look, it feels like you could simplify, but this is in the radical and this is not, so you're done. All right, starting from number 28, there's something called the conjugate. I'm probably going to spell it wrong. I think I mixed up my J and my G. But what the conjugate means, and if you look at how this is different from the previous one, this just had like 3 times rad 3. So all I cared about was the rad 3 and it was gone. But this time it says 2 minus rad 3. So I can't just multiply it by rad 3 because then I still have the radical when I distribute the 2. So there's something called the conjugate, where if I had 2 minus rad 7, the conjugate is 2 plus rad 7. Or if I have 2 plus rad 7, the conjugate is 2 minus rad 7. This one's going to be a workout. I understand. I'll go slowly. So when I look at this problem, the 4 is fine, the 2 is fine, but what makes this not fine is the rad 3. Now I can't simplify the 4 and the 2, because the 4 and the 2, it would work if I had this problem. Let me show you. If I had 4 divided by 2 rad 3, since they're being multiplied, I could simplify it. But since they're being subtracted, the rad 3 is here and the 2 is here. They're separate things. So if I simplified, I wouldn't get the same answer. And what I want you to see is if I had 6 over 3 minus 1. If I just went like this, it's not the same answer. Because if I had 6 over 3 minus 1, 3 minus 1 is 2, 6 divided by 2 is 3. But if you subtracted or divided here, 6 divided by 3 is 2, and 2 over negative 1 is negative 2. The answers won't be the same. Okay? So, let's go back. The conjugate, excuse me, I apologize. If this is 2 minus rad 3, what I need to do is multiply by 2 plus rad 3. Now, if I do it to the bottom, I have to do it to the top. Okay? And I will review this one again, of course. This is difficult. So what I'm going to do is I'm going to first start with the top. I'm going to distribute the top. 4 times 2, 8. And then 4 times rad 3 is 4 rad 3. That's the top. The top isn't so bad. It's the bottom that might be a little bit of a workout. So I'm going to actually show my work down here. It's not very conducive. Actually, I'll do it on paper. So if I had 2 minus rad 3 and 2 plus rad 3, when we're multiplying, we're going to multiply the first one times there. 2 times 2 is 4. 2 times rad 3 is 2 rad 3. Negative rad 3 times 2 is negative 2 rad 3. Always put the number and then the radical. And then rad 3 times rad 3, square root of 9, which is just 3. But then there's a minus there. Now what's supposed to happen is the radicals are gone, because that's the whole point of the bottom. And then 4 minus 3 is 1. Now, some of you didn't learn FOIL. Some of you learned the box method. So let me show you the box. I could go 2 minus rad 3, or I could go 2 plus rad 3. Remember, 2 times 2, 4. 2 times rad 3, 2 rad 3. Negative 2 times rad 3 is negative 2 rad 3. And rad 3 times rad 3 is 3 with a negative. Now remember, if you learn the box method 90% of the time, more like 95, those are the same. So 2 rad 3 times minus 2 rad 3 is gone. And 4 minus 3 is your 1. Now what's anything divided by 1? Well, that's your answer. Okay. I know this is a lot. If you get everything else and not this, that's okay. But I want you to try it. Okay, let's look at this one. The 5's fine. The 1's fine. Actually, I have to stop because the video stops me at 15 minutes. So I'm going to pause and then I'll start again.